Hello, everyone. My name is Dos Francis from Sokoine University of Agriculture in the Department of Informatics and Information Technology from the College of Natural and Applied Sciences. I'd like to welcome you all in the YEESI lab, and the name of this course is actually called Machine Learning in Agriculture, with a course called YEESI103. Now, in this course, I'll be with Ms. Catherine Mangare to assist you guys and facilitate your learning as far as the YEESI lab is concerned. Now, we expect that at the end of this course, students should be able to describe the basics of the machine learning. Also, they should be able to build models that can solve classification, regression, as well as clustering problems using the classical machine learning algorithms. For example, linear regression algorithms, logistic regression, K-linear, the naive Bayes, decision tree, support vector machines, the random forest algorithms, artificial neural networks, and so much of the likes. Also, we expect that students should be able to build models using deep learning algorithms. For instance, the convolutional neural networks, the current neural networks, LSTM, and so forth. And finally, the students should be able to apply the machine learning algorithms to build models that can solve real-life problems. And the center of this this project is to solve problems regarding agriculture. So for instance, smart agriculture can be a good choice for this one. Now, to begin, what is actually machine learning? Machine learning is simply a branch of artificial intelligence that provides the tools and the techniques to help intelligent agents to learn from the past experience so they can reason and behave like humans. Now, this means that humans are blessed with what we call the natural intelligence, but apparently the machines aren't. So what we need to do is actually to make sure that the machines can reason and behave like humans in the environment. So we are injecting the knowledge, and since this knowledge is not natural, is what we call artificial intelligence. So, okay, at this point, we already have another term called artificial intelligence. Now, what is the main difference between artificial intelligence and machine learning? So in most cases, I've seen students and other people usually confuse these two languages or these two terms. And artificial intelligence is actually a big umbrella of which machine learning is found inside. Artificial intelligence can simply be defined as the branch of computer science that helps to create smart or intelligent systems that behave or reason like humans. Simple. Now, in order to achieve artificial intelligence, there can be a bunch of tools and techniques and approaches to achieve this, and machine learning is actually one of the tools to achieve this one. So this tells you that there can be other ways, and as far as this course is concerned, we don't need to go through all other methods, but machine learning. Now, there comes another terminology called deep learning. So deep learning is basically a subset of machine learning. And deep learning, the difference between deep learning and machine learning is in machine learning, you have classical machine learning algorithms, but deep learning provides the deep neural networks with so many hidden layers. And we'll see and cover this in the future lessons. Now, why machine learning? So the applications of machine learning is actually everywhere in our daily life. And I know most of us are using machine learning, but some of us are unaware that we're actually applying or using the applications from machine learning or the AI. So for instance, we have what we call recommender systems. Have you ever wondered how in Facebook, when you log in Facebook, you kind of get what we say user recommendations, like friends recommendations, which is different. Like your recommendations and my recommendation are not necessarily the same. And this is because your recommendations are based on the choices, your age, the kind of friends that you already have, probably your location, your sex, and the kind of things you like, and your past experience using Facebook. We can also go to, say, eBay or Amazon if you want to buy items. Now, if you log into your page, the kind of items that are recommended to you are not necessarily the same that are recommended to everybody else. So again, it is based on probably the location, the kind of items probably you used to buy, the kind of friends, what are your friends buying, your sex, and so many features that are actually selected. So these are what we call recommender systems. The same applies in YouTube. You log into your YouTube account, I log into my YouTube account, we get different recommendation videos, right? So these are just based on our preferences, and so many other algorithms have so many inputs that is actually selecting these kind of items for everybody else. You can also go and see a speech recommendations, right? And speech recognition, and speech recognition and so many other language, natural language processing you see, like for instance, in nowadays, there are automatic, systems that are unlocked using your voice, and your voice and my voice are different. So the machines need to learn the patterns from my voice and difference or distinguish from everybody's voice. You see, so those are kind of applications where AI and machine learning is applied. Email spam detection, right? So you can have a system that detects that these emails may be spam and these emails may not be spam. So all these are other applications of machine learning. What about the stock market prediction? Okay, the value of the stock market is also based on what we call regression. So you're predicting the next value based on a random, a range of previous values. So this is another example where we use machine learning. Traffic prediction. I know in most of our cases, like in most of our roads, we know that the traffic lights maybe are based on maybe some kind of a timestamp. You give you like a count, probably some few seconds. You allow this side and a few seconds, allow the other side, and all the sides, it works the same. But in smart cities, these traffic lights should be able to see the real data, like, okay, this place has so much vehicles at this moment, so I need to make sure that I allow this side first and this side will come later, right? So if it acts on the environment, based on the circumstances on the current situation, that is using artificial intelligence to decide. What about the autonomous cars? I'm sure you have heard of these kind of cars, right? These are what we call the self-driving cars. If this car doesn't have a driver, then who sees that if there is an obstacle? Who tells the car to apply brakes? So it needs to learn from the environment and learn and the right decisions to make in every kind of situation, right? So this is actually another example of what we call machine learning. The same applies to face recognitions and a bunch of other applications. One thing I know for a fact is, even in our mobile phones, we have so many applications that are based on machine learning algorithms to decide and detect and do so much of the decisions, but some of us are not aware with some of them. Now, the types of machine learning. Machine learning can be categorized into different kinds. Now, mainly we can categorize machine learning into three major categories. This is supervised learning, unsupervised learning, and reinforcement learning. But however, in some other literatures, you find the semi-supervised learning. So I thought it is important if I just include it in the lesson as well. Now, one thing to understand is semi-supervised learning is actually a hybrid of supervised and unsupervised learning. So if you understand how supervised learning works and the difference from supervised and unsupervised learning, it shouldn't be hard for you to understand what is actually a semi-supervised learning. Now, supervised learning. Simply, supervised learning is actually a type of machine learning where you have what we call the training data with labels. I know it might be a little tricky, but let me give you a very simple example, like real life example. So for instance, you have kids, like students are just learning, right? Now, assume like you're training these students the way you're training a machine. This is actually what happens. The first thing you need to do is go through the training phase. In the training phase, you need to have the training data set, or simply the training data. And this training data set, you can just take it as a group of questions, a bunch of questions with answers. So you just tell these students, like, you have these questions, and a lot of questions with answers. And now you want all these students to learn the questions and the answers, absorb them and understand them, so that later on you ask them questions. You understand? Now, the questions that you're going to ask later on, there will be questions without answers. Now, simply because you have already trained these students, you want them to get as much questions as possible. So that's where you are measuring the accuracy of your model. Now, for instance, in this example, you have an input data, a collection of fruits, okay? And these fruits have the labels and they're called apples, okay? So now you train the model, and in the testing, you just take a sample fruit without, a label, right? And ask the computer, like, what kind of fruit is it? Because you have already trained it with so many fruits, it should be able to say that this is an apple, because you have given it apples before, and you have told, like, apples have probably this kind of weight, maybe they have the texture. It depends on the features that you're going to extract from the item. Now, you expect that the model is going to get it right, correct? Okay, this one is kind of simple. Now assume that you have, 2 or 3 different kind of fruits, or maybe you can have an apple, you can have, bananas, you can have pineapples, you can have mangoes, oranges, and so much of the likes. Now you're going to train the model by telling them this is a banana, right? It has height, which is different from, an apple. So you're going to provide all the possible features that can help it understand. So the next time it sees a banana, it knows from the features. The same applies to all different categories. Now, later on during the testing, you just use a sample amount of data, and without the labels, you're going to ask it, if you have learned correctly now, you tell me what kind of fruit is this? So this testing data is actually an incoming data set that doesn't have the labels. Now, remember, the key is to actually make sure that this model that you have already trained can get it right as much as it can do. Now you measure it using the precision, recall, F-measure, accuracy, and so forth. So we'll cover later on how do you measure the performance of a machine learning model. So the same applies to the student. If they get as much question, you just measure the accuracy. Like the accuracy will be the amounts of data that they get right, divided by the total amount of data, and they just get the percentage. Now you have to be very careful, because here you create a problem that is very common. Actually 2 problems that are very common. One is called overfitting, and another one is called underfitting of the model. Overfitting and underfitting of the models, what is the difference between these two? Overfitting is simply when you have too much training data set and a very little amount of testing data. For instance, I have 100 questions with answers, and I train these kids. Assume that this kid is a machine now, so they get as much information about these questions over and over again. And later on, from 100 questions, I just selected 5 different questions to ask them in the testing data. You remember that these questions doesn't have answers. So because you have used so much training data and you have used a very little testing data, so the probability is the chances are high that these students might get as much of them right, and the accuracy might be very high. But because the accuracy is very high, it doesn't always mean that the model has learned correctly. Problem, it is just overfitting. So that is an overfitting problem. And an underfitting problem is actually vice versa, where you have a very few amount of training data and you have a huge amount of testing data. So I just give you 5 questions with answers, and I give you like a lot of, I can use 10% of my data for training, and I give you like 90% of the data for testing. So the chances are very high that you are likely going to miss a lot of questions, not because you're not a good model, because it has been an underfitting. Understand? Okay. So the key is to make sure that you balance. Now, in balancing, there are some different ways in choosing between the training and the testing data, and we'll cover them as we proceed further in this course. Unsupervised learning. Since you know that supervised learning is you training the model with what we call the training data with the labels, like the questions that you're giving the student in the training have answers, and supervised learning is quite the opposite. You are going to be trained with the training data, but this training data doesn't have the model, doesn't have the labels. All you have to do is learn as much as you can on your own. So you're telling the machine to learn on its own and classify or categorize this data basing on their similarities and differences. I'll give you an example, okay? So right now you can have a group of students, like, okay, just a bunch of people. And I can tell you that from a group of those people, just give me 5 different categories, okay? Easy. I can start with maybe the gender. With the gender, I can give you 2 groups, okay? Like women, men and women. You see, automatically I just created my own categories. These are what we call clusters. And I can also decide to say, okay, so you have older people, you have younger people, like you can have very old people, like mid-aged people, and you have like kids, you see? So, okay, it can be one of so many ways to do this. The same applies in the computer when it learns. This time, so for instance, in our example here, we just provided with a bunch of fruits and want them to classify it according to their similarities and differences. So it can use height, it can use, the number of items, it can use color, it can use, weight, height. It can use a different kind of features and a lot of kind of features to choose from and create what we call clusters. And here, that's where we get what we call the clustering algorithms. Now, let's go to semi-supervised learning. As we mentioned earlier, supervised learning is actually a hybrid between unsupervised and supervised learning. So what you do here is you kind of fit your model into having some kind of training data with labels and some training data without labels, and you want it to predict or classify a new and coming data. And the third option is what we call reinforcement learning. Reinforcement learning is also known as the feedback learning. This is actually basing on rewarding and punishing an intelligent agent. So if it gets something right, you reward it. If it does something wrong, you just punish it. So for instance, this will be similar to when you are training your dog at home, right? So if your dog does something right, and according to what you want, you just give it a reward. In this case, you're encouraging it to do something of the like in the future in case similar problem or similar scenario arises, okay? But if it does something wrong, then you punish it. So it relates that this is actually not a good thing to do. You are discouraging it almost all the time when it does something you don't like it. The same applies to the machine. So you're actually taking the intelligent, you're taking the agent and expose it to the environment and let it decide on its own. If it does something you like, you reward it. If it does something wrong, then you punish it. This is all you have to know about reinforcement learning or feedback learning. Now, the machine learning algorithms. There are a bunch of machine learning algorithms. Now, we have just created some of them for your learning, but you'll see the other materials and online sources where you can learn as much algorithm as possible. And you should also know that not each algorithm is suitable in all kind of environments. Also, later on, you'll just learn and decide when to use this one and the difference with this one, the effectiveness and the efficiencies, and so forth. So as we mentioned earlier, that machine learning can simply be defined in supervised, unsupervised, and reinforcement learning. And in supervised learning, mainly you're solving two kind of problems. Remember, in the expected learning outcomes, we said at the end of this course, you should be able to build models that can solve classification problems and regression problems, okay? So classification problems is simply when you're trying to classify. You have categories or classes, and you need to kind of decide when this object, this data, where does it belong? Does it belong to actually category A, category B, or category C? You're classifying it. This is a classification problems. And there is what we call, so for instance, you can classify an email to whether it's a spam or it's not a spam. And in regression, that is when you're predicting. So regression is basically a prediction problem. So for instance, I can say, if we give you as much data, we just take this data and feed into the computer, maybe the weather data, right? From like 10 years ago. So you're telling it like this year, there were this kind of information and this kind of, weather. Just find as much data, as much information as possible. And you predict like, okay, because of this weather, they need to rain in this, time of the year. You see? So next year, there's going to be something different. You have data that from next year, and maybe this was the amount of rainfall, and maybe probably didn't rain. So there can be a bunch of outcomes. Now you are feeding this information to your model, and you want it to predict, based on these previous values, what is going to be the next value. Probably it's going to be raining this year, because these are similar situations like based from 3 years ago, or maybe it won't be raining. So now the key into succeeding in creating or building accurate model is to train as much data as possible. So we need to have as much data set in whatever kind of problem that we're trying to solve in machine learning or machine vision, because machine vision is actually, the goal of this whole year's project. So make sure that everything you're learning now here is to help you assist throughout your machine vision problem. Now I can mention some examples. In classification, you have the classic naive Bayes classifier. This is actually a probabilistic model, and it has some strengths and weaknesses. I'm going to teach you like in the later phase of this course when we're starting to implement in the programming part. And we have decision trees, we have random forest, we have support vector machines based on the hyperplane, we have the k nearest neighbors. This is actually, I mean, the simplest one probably in my opinion, which help you and build foundation into learning higher models. And in regression, we have a bunch of regression algorithms for prediction like linear regression models, the neural network regression, we have support vector regression. This is actually an SVM, an SVM kind of version for regression. And you have decision tree regression, lasso regression, ridge regression, and so forth. And in clustering, I told you, clustering is actually from unsupervised learning, where based on the similarities and differences of the data, the machine has to classify and cluster this data based on their similarities and differences. Okay, so you can do this. The most common algorithm in clustering is what we call the k-means clustering algorithm. You also have what we call the hierarchical clustering or agglomerative clustering. You have a DB scan clustering, you have Gaussian mixture model, and so forth. And reinforcement learning is actually based on decision making. As we said, we're exposing this intelligent into the environment and want them to decide. And then based on the punishments and the rewards, you can have Q learning, R learning, TD learning, and so forth. Now, the deep learning neural networks. The deep learning neural networks, this is actually a part of machine learning as we discussed, but there is a very, big difference between the classical machine learning algorithms that we actually discussed before and these deep learning neural networks or the deep learning algorithms. Now, the deep learning algorithms, it has three main layers. The first one is what we call the input layer, and we have the hidden layer and the output layer. Okay, so the hidden layers, there can be, a bunch of layers, a bunch of numbers of layers. Your hidden layer can have, anything from 1, 2, 3 to hundreds of hidden layers to like very, very deep neural networks. Now, what these layers do, they do a lot of processing, taking data from previous layers and processing them, then feeding the results into the subsequent layers, fine-tuning them then to subsequent layers, and eventually you get what we call an output. So the input of these, deep neural networks, these are just neurons with, a vector space. So for example, in this input layer, layer 1, you have from a vector space from X1 to XP, and these are just a bunch of inputs where they have to be processed. They can be images, they can be text. It depends on what you are trying to classify. Now, at the end of the day, you need to have the results. Now, apparently, we have just discussed, the basics and the types and everything, but you need to know that the main concern here is to actually make sure that we use the skills from the machine and deep learning algorithms to apply them in agriculture. We have to do as much research in agriculture in machine vision. So remember the key term, machine vision agriculture. Even the name of this course is machine learning in agriculture, which would help you create the basic foundation, understanding, and fill you with the right tools to go and apply and do your research and solve problems regarding machine learning, machine vision in agriculture. So thank you all for your attention. I'll see you guys in the coming lectures.